we will see how to design or check our design using SAP and perform the needed changes to the member selection, considering the American sections that we are designing using in this course. By the end of the previous task, you already designed the beam and beam columns, and you arrived at this section in front of you. Here, this is an example, so you can see I'm using the same section for the beams and the columns, but you might have a different situation. The same model that you built in the previous task, but you will go through some additional steps to check these sections. So the first step is to define the sections considering the built-in tables within SAP. So as you can see, you will go through define section properties, frame sections, and then you will import new property. Choose this file, which is aisc.pro. This is the American sections. You have also several different American sections, but let's choose the first one. And you previously defined that you will use I-beams. All the sections. So this will give you the ability to choose any sections that you prefer, or you can choose selective sections. It's up to you. Or assigning the sections that we defined to the different members in the steel frame. So you need to select them. And as you know, in order to select, you need to right click on each member, or you can use the rectangular selection too. See, you will select or assign to these frames the sections that we introduced at the beginning of the lecture, which is W12 times 558, and you will press OK. When you do so, you will see that this section is assigned to the different members that I have. If you have different sections for the beam and columns, then you will select these and assign, and then you will repeat the same step with a different section for the columns. To go, you can see we have the assigned sections to the different frame members. Learning how to use the design module implemented in SAP. So as you can see, there is a tab here called design. So you will go through steel design, frame design, and the first step is to design the compost used for design. So you need to follow the same selections as listed in front of you. To change some parameters to make sure that the design is correct. So choose first the two columns. Through design again and choose in this time view or revise overrides. Everything as it is except for these parameters. So you have the unpressed length around the major and the minor axes, and you have the effective length factor K1. So you have Kx, Ky, and the different values. So for the first three, this is the unpressed length over the total length of the column. So you need to go back to the general layout drawing and see what is the spacing between the side girths. So you will take the spacing between the side girths and divide it by the total length of the column. This will give you this factor. If you are using, let's say, a wall across the whole length of the column, in this case, we might, in some situations, we might consider that the wall will prevent the column from having any unpressed length, so put a very small value. And then you know how to calculate the Kx and Ky using what we learned in the chapter 5 for compression members. So it's exactly the same. So you put the values as you can see in front of you. For the beam, so select the beam as you can see. Access also the steel frame view or revise override, or to modify these three factors only. So the unpressed length over the total length of column, this will be the distance between the purlins that you defined in the general layout over the total length of the beam in this case. The analysis, and after you run the analysis, we will see how to check the different sections. The analysis and you have the results, go through design, steel frame design, and then start design or check of the structure. And then give you a color for each member. This color is really important and it shows you the stress ratio. but also you need to see the value in order to be able to take decisions. So to see the value, go to design, steel frame design, and then display design info. As long as you have a value of stress ratio here less than 1, this means that your design is safe and good to go. If you have a very small value, then you can change your members by decreasing them to get a more economic design. Note here that the frame is symmetric, but we only introduce the wind load from one direction. That's why you will not get the same stress ratios for the whole members, but we will design using the most critical one. And experimenting with the program till you have stress ratios that you are happy with. And then you can move to the design of the bracing members. Bracing members and the horizontal bracing members. So let's start by the vertical bracing members. You need to introduce or to extract some parameters. So if you have a shape that looks like this, you need to get this length, which is called Lx. And in this case, Kx is equal to Ky is equal to 1. Lx, as you can see from this figure, and then Ly is equal to 1.5 Lx. Include an additional horizontal bracing member. In this case, you have Lx as shown, and Ly is equal to 1.2 times Lx. Horizontal bracing, you will calculate also Lx as you can see, and Ly will be equal to 1.5 Lx. Now, in order to choose the section, we only have the slenderness condition. So KLX over Rx has to be less than 200, and the same for KY-LY over RY. To get the value of Rx and Ry, and then go through the tables. We have tables considering double angle back to back. You have equal leg and unequal leg. Usually we go for the equal leg, and you will choose sections based on the value of Rx and Ry. Example, so I got Kx Lx over Rx. I have these parameters from the general layout. So I calculated the Rx has to be larger than 50 millimeters and the Ry has to be larger than 22.5 millimeters. Now I access the tables, and here you can see I have the value of Rx, and here you can see I have the value of Ry. And when you look at the value of Ry, you will see that you have 3 columns. So choose the one in the middle. This is different spacing between the two angles. Usually we go for the 9 millimeter. And based on this, I found that the sections that can be used is to angle 2 times 2 times 3 over 8. So this is the design for the bracing members. You need to do this for the horizontal bracing and the vertical bracing. So this simple calculation, you need to perform it twice.